Hello students, in this class we will discuss BSc second year, 4th semester algebra, some of the important questions. Okay, so before discussing these important questions, we will have some of the definition. Okay, definitions are really important to you in this algebra. Okay, so we have group theory and ring theory in your algebra, right? I'm going to start unit 3, that is the ring theory. Okay, so before discussing this one, we will discuss all the definition which comes under this rings and integral domains, maximal primes, ideal primes, all this we will discuss so that it will be helpful to write down the theorems, right? So first of all, how we have the group definition, it should satisfy some of the conditions. Similar way, we have the ring properties also, it should satisfy those conditions, then only we will say that set is nothing but a ring. Okay, now first we will discuss about the ring definition. Ring is nothing but a R, okay, one of the set. It should satisfy the following conditions under addition and multiplication. Okay, R under addition and multiplication, it should satisfy certain condition. What are those conditions? R under plus is an abelian group, first condition. R under multiplication is a semi group. Okay, and also it should satisfy the left and right distributive laws. Already you know the distributive laws, so R should satisfy these distribution laws also. If these three properties set going to satisfy, then we will say that set under addition and multiplication is a ring. Okay, so many definitions we have, students, like commutative ring, units of a ring, idempotent element, nilpotent element, boolean ring. Okay, you can see in this paper. Anyway, we will discuss this all in theorems again. Okay, so like this, subring. Okay, how we have for group we have subgroup. No, similarly for ring we have subring, means it should satisfy minimum of the ring properties. Okay, so under the same operations. Okay, a ring of a subring of a ring R can be defined as a subset of a ring which itself is a ring with some operators on R. Okay, so similarly we have ideal of a ring R. If it satisfies these two conditions only, we will say it is an ideal of an R. Okay, it should be a non-empty set and it should satisfy, mainly you have to remember this condition, student. RS belongs to S and SR belongs to yes, left and right laws, it should be satisfying. Okay, so a non-empty set of S of a ring R is a subring of. In some theorems we are going to prove these two conditions, so that we will say that it is a subring. Okay, and these all are the also very important questions, students, definitions, because with these definitions only we are going to write down the theorems. Okay, so once we will discuss these all definitions. Divisors of a zero in a ring. Okay, so what is our divisor of zero in a ring? If A and B are two non-zero elements of a ring R such that AB is equals to 0, then A comma B are said to be a zero divisors, where 0 belongs to R is a zero element. Okay, so what is the condition, student? A comma B are non-zero elements. First of all, those should not equals to 0. Okay, so what condition it should satisfy? Such that AB is equals to 0. AB is equals to 0 such that A comma B are said to be a zero divisors. Okay, if A is not equals to 0, okay, and B is not equals to 0, our product AB should equals to 0. Okay, if any of these three it's not satisfying, we will say that it is not zero divisor. Okay, if they are going to satisfy A not equals to 0, B not equals to 0, the product is equals to 0, then we will say that it is a zero divisor of a ring. If it is not satisfying, simply we will say that no zero divisors. Okay, next we have a integral domain. What is the integral domain? A commutative ring with unity. Already we have previous commutative ring with unity definitions also. a commutative ring with unity containing at least two elements having no zero divisors. Okay, so what they are asking here, we have seen the zero divisor definition. Okay, if commutative ring with unity, if it has not satisfying the no zero divisors, then we will say that it is an integral domain. Okay, first of all, it should be a commutative ring with unity, any two elements, it should not satisfy this condition. Okay, zero divisors, it should not satisfy, then we can say that that is an integral domain. Okay, next, field. What is a field? A field can be defined as a non-zero commutative ring has a multiplicative inverse for every non-zero element. Okay, it should be a non-zero commutative ring. Okay, and for a non-zero element, it should exist multiplicative inverse. Okay, so non-zero commutative ring, that should exist a multiplicative inverse, then we are going to say it is a field. Okay, next, characteristic of a ring R with unity. So the characteristic of a ring R is defined as the smallest positive integer n. Okay, any positive integer n we are going to take, such that n into a is equals to 0 for all wherever a came from the again ring R. If no such integer exists, suppose n here existing, no, if such no integer exists, we say that R has characteristic 0. Okay, 0 into a is equals to 0, like that we are going to take. The characteristic of R is denoted as char R. Okay, characteristic of R. This is also one of the important definition to write down the theorems. Okay, right. So next, how we have characteristic of a ring R with unity. Similarly, we will see that characteristic of an integral domain. Okay, so R under addition, under multiplication be an integral domain, and A be an element of a ring R. The characteristic of a integral domain is defined as the order of an element. Okay, na? So you know order of an element is nothing but a power n is equals to e. We are going to find out the order of an element. So if it satisfies, then we will say that characteristic of an integral. Okay, so and these are all the unit 4 definition. First of all, we will see some theorems about unit 3, then we will go for the unit 4 definitions. Okay, right. So here we have seen divisors of 0 in a ring, integral domain, field, and characteristic of a ring R with unity. Okay, based on this one, we have 3 to 4 theorems which are very important. We will discuss in the next video. Okay, right.